Got a new problem for you. So, we have an initial momentum of negative 2.85 I hat plus 4.05 J hat. A force is applied to this initial momentum of 0.290 T I hat minus 0.495 T squared J hat. So we need to find what is the final momentum after 1.95 seconds. So here's what we need to do. I don't want to demonstrate necessarily just a solution. I want to demonstrate the thought process that led to me getting to this solution. So really, we just need to start off with one equation, which is F equals ma. Believe it or not, we can derive everything we need from this one equation. What do we know about A? Well, if we need momentum, so momentum is mv, we want to relate our force to a velocity somehow. Well, what's A? What's acceleration? It's the time derivative of velocity. So we have F equals m dv dt. So now what happens if we move the dt over to the other side? Essentially, we have F times t equals mass times the change in velocity. I hope that logic follows based on what I just did here. The t gets moved over, but this is not the end of the story. This is not the end of the story. This is a little bit of t getting pushed over to the f, which means that it's going to be an integral, f dt. And what is mass times the change in velocity? Well, we know that mass times velocity is momentum. So that means that mass times the change in velocity is the change in momentum. So that means that the integral of force, the time integral of force, is equivalent to the change in momentum. So by definition, what is the change in momentum? The change in momentum is final momentum minus initial momentum. And that's exactly how we're going to get our... that's exactly how we're going to get our equation. So here we go. So what are our integration boundaries going to be? Just looking at our problem, if this is a time integral, then our boundaries of integration are going to be 1.95 and 0 at the bottom. And this problem, just looking at it, is perfectly set up to do a time integral. I mean, look, you've got t right there in the force vector. Like that doesn't get better than that. I mean, come on, let's be real here. So we have 1.95, 0, and our force is 0.290 t. So that's 0.290 t. That's supposed to be an I hat, my bad. And then we have minus 0.495 t squared j. 4 t squared j hat. And so now we take our initial momentum, just add it to the other side. So we have essentially here is that our force integral plus the initial momentum equal to final momentum. I mean, right there, like, you've got it from this point. You just plug and chug with the calculus, and then you're set. But I'll just do a little bit of a short rundown just to make sure that, like, everything's understood. So we have then our... Since I can't write all the way on that side, we're going to have our minus 2.85 I hat, 5 I hat, plus 4.05 j hat. There. So now, time to break out the calculator because we're about to do some integration. Okay, so if we're going to anti-differentiate this portion of it, we have 0.290 times t squared over 2 plus, pardon me, that's a minus, that'll mess up your whole problem if you get that. So then we have 0.495 t cubed over 3. And if you have trouble with the anti-differentiating portion of this, I would highly encourage you to look up any other videos about this that you can find on YouTube, because it's a very, very important concept for a problem like this. And this is all being integrated from 0 to 1.95. And we cannot forget that after this we need to add in everything else. So then we would have 0.290 times 1.95 squared over 2 plus, that's a minus, 0.495 times 1.95 cubed over 3. And then if we put 0 into those t's there, it's just going to get zeroed out. So we end up with a big old minus 0 there. And so then we take this and we, number one, we subtract 0.85 I hat minus 4.05 j hat. Don't be like me and always remember to put in your I hat and your j hat, or else you might end up adding up the wrong things together. So this is just algebra. So I'm not going to go over the algebraic portion of this, and we're just going to say that it is minus 2.2986 I hat plus 2.9007 j hat. So I hope that it makes sense how exactly we decided to approach this problem, all starting off from f equals ma and taking a derivative in order to find out exactly how we can relate it to momentum. Because really, just write down equations, always start off with that and see how you can relate other variables to each other. Like, how does acceleration relate to velocity? Little things like that can really get you started on a problem like this, because otherwise you have no place to start and you have something that intuitively kind of makes sense, but putting into terms of math is impossible without calculus. So I hope this helped. Stay tuned for the next one.